works very much. After this. That's the when it comes
Okay. Gary, we ready? Okay, let's begin. It's my privilege to welcome you to the University of Tennessee Nuclear Engineering Department Colloquium Program. Before I introduce today's speaker, there are some students that I would like to recognize. As most of you know, each year our students compete in the National Student Design Competition sponsored by the American Nuclear Society. And they usually do quite well because we always have good students. And the last few years has been no exception. A&S provides certificates to these students, and I've already given out some, and I want to give out two today. I have 3 students to recognize, but one of them is not here. The first student that I want to recognize is Bafu Lu. So Bafu, if you come down here. These are design students that won the National Design Competition. Congratulations. Thank you. And then the second student is Zhao Ka. There he is. Congratulations. And then the third student is Thomas Miller, but Thomas couldn't be here today. We'll see that he gets his certificate. Okay, now for today's colloquium speaker. The speaker is Mr. Harold Denton, who is the former director of the Office of Nuclear Reactor Regulation with the U.S. Nuclear Regulatory Commission. Let me read some of his bio, which usually I don't include this much, but this is rather impressive, and so I want to read some of it to you. Mr. Denton retired from the U.S. Nuclear Regulatory Commission after more than 30 years' experience in the regulation of civilian nuclear reactors and in risk communication. He was the director of the Office of Nuclear Reactor Regulation for almost a decade. In this position, he was responsible for assuring the safety of all nuclear power reactors, test reactors, and research reactors, and was the only official authorized by the Atomic Energy Act to issue construction permits, operating licenses, and shutdown orders. He issued over 40 operating licenses during his career. Following the accident at 3 Mile Island in Pennsylvania, President Carter appointed Mr. Denton as his personal representative at the TMI site. As a nuclear safety expert, he has visited essentially all U.S. power reactors and has traveled extensively to nuclear facilities worldwide. He was in the first group of Americans allowed to visit the Chernobyl site and was instrumental in establishing nuclear safety cooperation with the USSR. He has a degree in nuclear engineering, and we won't hold this against him, from NC State, and has attended graduate school at the University of Maryland. Since retiring, he has provided advice on nuclear safety matters to a variety of national and international clients, including the Department of Energy and its national laboratories, private utility companies, and the governments of Austria, Japan, Sweden, and Taiwan. The subject of his presentation today is a history of civilian nuclear reactor regulation from a regulator's point of view. So, Harold, welcome.
Thanks, Lee.
Well, it's good to be back, and it's here, and I'm really glad to see so many attendees for these things. You hear a lot of talk about nuclear programs shrinking. Well, yours looks like it's growing.
It is growing.
I'll jump right in the topic. I never intended to make a career out of working for the federal government. I don't think anyone ever does. I worked at the Savannah River plant. I had a real job at Savannah River plant playing physicist, but they had no interest in commercial power, so I joined the smaller outfit called the Atomic Energy Commission way back when President Kennedy was in office. And pretty soon I found myself staying there longer and longer and longer, and I stayed there till Clinton's first term was over. So I've been retired for a few years, and it's kind of fun to see the world from the outside of the federal bureaucracy. I'm going to give a quiz later and ask people who recognizes this picture, or does anyone know who they are? That is Dr. Cliff Beck at NC State receiving the first commercial fuel shipment ever made. They're two armed guards from Oak Ridge that came over with the uranium sulfate solution and delivered it to the newly built homogeneous 10 kilowatt research reactor in Raleigh, North Carolina. And I thought that was a good one to illustrate how far we have come, from when the fuel arrived at the front door like that. And Dr. Beck signed some papers, and it arrived in December of '53. And remember, up to that time, all reactors had been owned by the federal government. By Christmas of '53, they had the solution poured in the reactor, and the reactor in operation. So that's why I titled this talk From License R1 Forward. And they really did issue, the AEC really did issue a license called R1 for that first reactor. I want to talk about regulation of power reactors, though, more than research reactors. I divide the period in which I sort of watched the regulation closely into 5 periods. The first period is what I'd call the period of minimum regulation, and I'll come back and talk about these. This is when the government really wanted to get power reactors built in a hurry and wanted to encourage a widespread use of nuclear power. The second one was what I'd call the bull market or growth market. Every power company in the U.S. wanted to have a power plant, and the field really took off. I've shown on this chart the number of construction permits issued per year. I've only shown the permits that actually went on to turn into operating licenses. There were a lot more proposals that didn't make it. Then we went through the TMI, the Chernobyl phase, and I'll talk a little bit about those, how they affected the agency. The next one, for about 10 years, the commission muddled around trying to decide was it going to use PRA or deterministic methods to regulate. And now we're in what I call the counterintuitive phase of operation, in which plants are operating better than ever. And it's just remarkable how well plants are running today. Many of the plants produce power around 1 cent per kilowatt hour. They're just cash cows. And you probably noticed that the sale of the Seabrook plant went for $850 million roughly, which amounts to about $1,000 a kilowatt. So people are once again buying plants and making money generating electricity. And then finally, I want to talk about the future. What might the future, what are the issues that the future might hold for us? This is Dresden 1. It was really the first successful nuclear power plant in the U.S. A lot of federal money in it, but Commonwealth Edison put up a lot of money. I've listed on the side of the slide here some of the things that happened during this period. Feel free to interrupt me if you have any questions. I like to be pretty informal and get feedback. From the NRC standpoint, the main focus of our review at this time was on the reactor core and the control and instrumentation system, and a little bit on reactor fuel. But there was really no focus at this time on the management of the facility, on training of operators, on emergency planning. Everyone thought that nuclear engineering revolved around the reactor core, so it's a lot of attention, as you would guess, on those aspects. I say here that 14 plants were operating and under construction by '62. Then let's look what happened the next time. I've picked this bull from the bull market, stock market picture. Everybody wanted a nuclear power plant. There were so many applications arriving at our little office in Bethesda that we established a rule that we wouldn't accept more than one application a week. So we made the utilities line up at the door, if you can believe it. And there were a couple hundred applications came in for power plants during this period. It was just an amazing growth period. And if any of you had walked by our office during this period, we would have pulled you in and put you to work. I mean, we hired everybody that we could find. The agency was just growing like topsy, and plants were beginning to operate, so we were beginning to realize that we needed more than reactor physicists in the staff, and we were beginning to hire across the board civil engineers, mechanical engineers, heat transfer, metallurgists, materials people, and really began to look at the important, what we thought then were the important issues. I should mention that all commercial power plants in the U.S. have always had containment. You may wonder where the first containment came from. I had that same kind of question and went back and did my own research, and the best I can find is that the old Atomic Energy Commission established a committee headed by Edward Teller called the Reactor Hazards Advisory Committee or something like that. And they reviewed a proposed Navy reactor in New York State and required a containment because the power level was fairly high and the town was nearby. And since that time, every U.S. power plant has always had a containment. Any questions on the bandwagon years? I mean, what you really had going on here, you had the salesmen from GE and Westinghouse and B&W meeting on the golf course with the presidents of the utilities saying, wouldn't you like a power plant? And they were so cheap, they were just selling left and right. Now maybe Bob can add a little background from his point of view on that. But yes.
What was your particular reason for the China syndrome there?
Oh, the China syndrome got invented during this period. The ACRS, the Advisory Committee on Reactor Safeguards, was meeting on Dresden. Dresden 2, I think, was one of the plants that had been proposed. And somebody on the ACRS said, what would happen if the core cooling system fails? You know, Dresden 2 was a big reactor by that time. And he asked it of Roger Boyd. I don't know if you remember that name, Roger Boyd. He said, well, I guess the core would melt right on China. And that's how it kind of got started. And when I was a kid, I dug in the backyard, mother would say, keep digging, you're up in China. And I've often wondered if Chinese boys were playing in the backyard digging, if their mother told them, you keep digging, you'll end up in America or South America or someplace. Anyway, that's as simple as the idea arose, China syndrome, and it was just shorthand for saying that if emergency core coolings don't work, you've got a hell of a mess. And it took a lot of research to find out what a hell of a mess means, but that was how the idea got started and talked about.
It was a Calvert Cliffs.
Excuse me?
Calvert Cliffs.
Calvert Cliffs was the first time, that was the first reactor where the courts ruled that an environmental impact statement was necessary. Up to that time, the AEC and federal agencies didn't have to do environmental impact statements. The agency thought that it was a technical agency. It didn't have to look at the spectrum of impacts. It didn't have to compare alternative fuels and that sort of thing. So that hit the agency hard because it was a slowdown in licensing, and the agency had to prepare environmental impact statements on every plant that was before it. And that's really started the whole movement toward environmental impact statements in the U.S. Other questions? Well, marching right along, this led us to the era that I'd call severe accidents are not impossible. Going into this era, the NRC got created by an act of Congress. Nixon was in office. Nixon did a lot of governmental things that you probably never got credit for, but one of them was he split the AEC into two agencies. One was NRC and one was the HERDA, which became DOE. When NRC got formed at that time, we didn't have any accounting department or purchasing department. We couldn't even buy pencils, so it took us a while before the AEC, DOE got all the good stuff. They got all the laboratories and that sort of thing, and the NRC was a bunch of bureaucrats like myself who could barely could run an agency. So it took us a while to catch up. We had the Browns Ferry fire. That was a real shock to the system, that fire turned into be such a big fire. The chairman of the NRC at the time was Bill Anders, former astronaut Anders, and I kind of remember that he chartered a plane and dashed down to TVA at the time at Browns Ferry, and I wish he'd stuck around longer. He stayed about 6 months, I think, with the NRC, and then he went off to be the ambassador to someplace and didn't stay with us. The Watch 1400 was published during this period and began to lay out the basis for probabilistic risk assessment that you know about. TMI happened, and I'll talk a little more about TMI. Chernobyl happened. Those two events were sufficient, along with the energy crisis in general, to result in no more new applications to the commission. So there hasn't been a new construction started since this period. There have been plants that were delayed that were under construction before this period that got licensed later, like Watts Bar. Let me move on to the TMI. Anyone want to take a guess at what's on the picture? What we're looking at? Core. Which part of the core? It's a fuel element, and there's the zirconium cladding element sticking up, and the pellets, of course, melted or fell out to the bottom. It's been well investigated. About half the core melted during this accident. It also showed how important the containment was. The maximum off-site dose from this accident was about 100 millirem to anyone standing at the north gate of the plant for the whole time of the accident. I got a call that morning when the accident happened. It didn't seem that important, so I did what any good bureaucrat would do. I sent my deputy over to the emergency response center. As the day wore on, it seemed more and more important, so about 4 o'clock I went over to the emergency center and spent the night there. By Thursday, it looked serious, but not, looked like it was getting better, I guess. So I went home Thursday night, get some sleep, and came in Friday morning. By that time, people will realize that there was a hydrogen explosion that had happened Wednesday. People had thought it was just a turbine noise. They began to realize that the high thermocouple readings were real. Heat steam in the plant. And I got a call from the chairman saying he talked to the president, and the president wanted someone up there to represent him, and I should go. And I remember telling Chairman Hendry, I think you should come on too, Mr. Chairman. He said, no, I'd better stay here with the commission because there might be some important votes to take, so forth and so on. I later had a chance to go down to the Carter Library in Atlanta and look at the notes that President Carter had taken on the phone calls that he and I had. They bring out at the Carter Library a tray, and it has on there all the documents that Carter saw or wrote that day. And what amazed me is you look at that each day, it's the same problems as the day. It's sort of trouble in the Middle East, how he's dealing with that. It's the energy crisis, it's health care. I don't think that the issues facing the presidents ever really change. And then every now and then there'd be a handwritten scribble on the phone calls that he and I had, or from his staff on TMI. I stayed up there 3 weeks after I arrived and did a press briefing in the morning, and then Governor Thornburg and I did one every evening. So we got along famously, and it went very well. By about Saturday, I had 100 members of the NRC staff up at the plant, so it wasn't just me, and utilities began bringing in their experts. I remember calling Bill Lee, president of Duke Power, and he owned 3 B&W plants, and saying that Metropolitan Edison was just falling asleep at the switch. They had been coping with this, and they were such a small utility. He immediately brought to the plant, along with himself, 7 or 8 senior reactor operators and other senior managers, and in fact, people from Duke Power were pretty much running the plant, if you call it running. When he arrived, no questions of legal cost or liability or consequences. I'm not sure that would happen today, that another utility executive would just come step in.
Could I ask you a question?
Sure.
Did you notice any particular expertise on the part of the president because of his nuclear background in your conversation?
Or ignorance, either expertise or ignorance.
He told me about being involved in the accident in Canada. What was the name of that reactor?
NRX.
NRX. And he was an ensign at the Naval Academy, and apparently they were all sent up there to stack up lead bricks and, and be helpful. So he remembered that period vividly, and he didn't try to step in and tell me what to do. He was very interested in what was going on, wanted to be called at 8:15 in the morning, 4:45 every day, and anytime anything happened, there was a report. So he had a red telephone installed in our trailer at the plant, and you could pick up his phone and say, the president asked me to call, and it connected directly to the White House switchboard, and they put me through. So for about 3 weeks, I could get anything I wanted that the government could provide. And I didn't always talk to him, but for example, it was clear that the filters in the auxiliary building, I think, weren't doing as good a job on charcoal as we thought they should. And the utility or industry or someone had found that there were identical filters out in the state of Washington at one of the WUPS plants. But they were difficult to, how could you get them all the way back across the country? Somebody tried flying them, looked into flying them commercially, and I guess the little airport out of Tri-Cities, Hanford, said we're not authorized to take such a big plane. So all it took was a call to the White House, the Air Force. Filters showed up at Harrisburg, within 6 hours, and they were installed and everything. So that's the sort of service that the government can provide if you've got a person on top. So it was just unique to have the president, even though the president didn't know me at the time, I didn't know the president. People thought I had the president's ear anyway. And if you ever worked in government, the appearance of the president's ear is just as important as the real thing. The only guidance that Carter and I ever got into was about running the hydrogen refiner. You remember they had the hydrogen bubble, and there was something about the refiner which escapes me now. They had 2 of them, and they wanted to rebuild them, and we started up one of them. And Carter wanted to know why we weren't running both recombiners. Well, the answer was that if something failed, if there was a common mode failure in the recombiners and they both failed, they'd be contaminated and they'd be much harder to repair. So the staff wanted to get one running, let it run for 24 hours roughly, make sure it ran okay before turning on the second one. And he was kind of edging, well, let's run them both. But he didn't direct us to run them both. So we let them age and actually got both of them running. I wanted to move to the bubble scare next and talk about that. And the fact that as a result of all the improvements after TMI, plants are much safer today by, factors of 50 or 100 or higher, depending on how you do the calculation, I think, than they were at the time of the plant. This is a rare curve. You may never see this curve anywhere else. I hadn't seen it for 20 years till I started throwing away my papers. And this is a plot of hydrogen bubble size versus day. And the way they measured it, they would turn off all water to the core, and or either pump water in, I guess, and do a PV calculation and see how much the bubble size changed. So you'll notice when the concern first arose, it was up here like 2,000 cubic feet of non-condensable gases, which we assumed to be hydrogen. And then once it got to he pointed out that it was very easy to do this with this mouse. everybody started coming to, wait, let's increase letdown flow. Can't account for this letdown flow. We thought about venting the bubble directly into the containment, but that seemed, you know, we really shouldn't do that unless we had to. I don't think anyone is quite sure how we got it down in just 2 or 3 days to where it is. The company claimed success about this time. I guess I can use the pointer here. The company was claiming the bubble was gone like March 30th. One thing I got pinged for in the Presidential Commission investigation was not calling the bubble gone sooner. But I think we were dubious because there was all this other data kicking around, and I didn't really call it success, you know, like when is the war over kind of thing, until it really got down and stayed down here. And it'd be a good project for someone to try to calculate how could you get the bubble down from 2,000 cubic feet in that short a period with normal letdown flows and so forth. I've often thought there must have been a leak in the system, or either someone opened the PRV and vented some of this into the containment. And I think we didn't want to vent into the containment until we had both hydrogen recombiners we talked about running to be sure we could get it down. But this one issue produced the biggest scare in the local area, because everyone knew there had been a hydrogen explosion in the containment. It was about 30 pounds pressure explosion. Of course, it didn't damage the containment, but the very idea that there was hydrogen in the vessel, and the NRC staff had just jumped right to the conclusion that there's oxygen present, which was a mistaken conclusion. What's the maximum pressure it can generate at a stoichiometric explosion in the containment? Will the vessel handle it? The commission, while I was meeting with Carter at the plant on Sunday, the NRC commissioners were about to request an emergency evacuation because of hydrogen bubble explosion. And we now know there never was a potential for a hydrogen bubble explosion because you can't get any free hydrogen in a situation like this because you got 2,000 pounds pressure of hydrogen over the coolant in the reactor. Talk about it more. It's a fascinating little piece of history. The main lessons learned, of course, dealt with operations, procedures. This is a cartoon drawn for the Washington Post by Herblock, and I thought it sort of captured the lessons learned. The operator says needs more work. The accident led to the formation of FEMA, the Federal Emergency Management Agency. At that time, we didn't have a FEMA. It led to the creation of INPO, operator training at every plant. You probably remember that before TMI, there were only 4 simulators in the U.S. Each reactor manufacturer had a generic simulator at their headquarters, like beautiful downtown Lynchburg, San Jose, and so forth. But plants didn't have their simulators. Now, of course, every plant has its own simulator. And I think that simulator and system-oriented procedures, the focus on coping with accidents before they ever get this far along, has really been the biggest contribution to safety. The hardware didn't change all that much as a result of TMI. The NRC, for its part, didn't have on-site inspectors before the accident. Now we have multiple inspectors at every reactor site, and they know the plant very well and are able to be there in case there's anything going on. This utility was called Metropolitan Edison. They were probably the least qualified utility to have an accident that you can think of, because it was very small. They didn't have they were very small subsidiary of GPU. They didn't have a large technical staff. They operated with a really minimal crew. They just didn't have the financial, the managerial, or the horsepower to cope with an accident that ran like this. And they were also inexperienced in dealing with the press. This is Jack Herbine on the right. He was the plant manager at the time. He's the one who told the press, I don't know why we have to tell you everything we do here. And Of course, the press practically assassinated him for those kind of remarks. The fellow on the right, Walter Price, was the owner and president of the company. And when I arrived there, he had a prepared press release, joint press release prepared that said today MedEd and the NRC say blah, 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 blah. I was new to the press game myself, but I did have the good sense to take along the head of our public affairs department, a guy named Joe Fouchard. Joe snatched that news release out of my hand and said, we're going to issue our own releases. We're not going to issue any joint releases with the company. That was probably the smartest thing. He earned his whole salary for the year by just that one move. So we never did hold press conferences. And in fact, the company was usually so inept that by about Saturday or Sunday, Jody Powell, the chairman's press secretary, called the company and in effect shut them up and said, you guys stop holding press conferences. You're only confusing the public and so forth. And so and the NRC became the spokesman for the accident. But the utility was always downplaying it. And for the first couple of days, they said, we're going to be back in operation in a few days, those kind of statements. And then when the governor and everybody else found out how serious the accident really was, they just really lost all credibility in the company. I was lucky by getting there after all that had happened, so I had a decent time. Always got the question, what's the worst that can happen? So no matter what else you did, you always had to talk about, well, the worst that can happen, you can have further core melting, you can have containment failures, you can have the release, you can have evacuation down. What I'd always try to say, but that's not what I think is going to happen. Here's the most likely thing to happen. I met the doctor who operated on President Reagan when he was shot in Washington, and he held a press conference on his successful removal of the bullet and so forth. He said he got a question from the public, from the press, saying, well, doctor, what's the worst that can happen? So it's not unique to nuclear matters. One other point, the nearby press was much better than the Farwood press. The press in Middletown and Harrisburg did a very good job of covering the accident because they lived there. It was published locally. They couldn't put out scare stories. But if you looked at the paper from Arizona, for example, you would have thought people were dying in the streets around Middletown. But people who lived in Middletown went about their jobs, and life went on. And I have a really high regard for the people there who stayed, the policemen and all the people involved in sort of law and order stayed there. Some things were a problem. You couldn't get the telephone company to install any new phones in the plant because they were afraid to. So they wouldn't come on the island. They would come out as far as the gate and install connections, but the plant people had to take it from there. And there were evacuations. There was never one ordered, but about 200,000 people left the area, according to studies done later, who decided it was a good time to go visit their cousin in Florida, kind of thing, which, is not a bad idea if you're unsure. So a lot of effort went into emergency planning after this, and while it cost an arm and a leg to the company, scared the heck out of everybody, it really has made plants much safer because of it.
Whatever happened to the epidemiologic study?
It's still, epidemiological studies are still grinding on.
I see.
Being done by the University of Pittsburgh and the Department of Health. And the last one I saw, which I think was a 20-year wrap-up, they find no discernible difference in the health of people who live around the plant or the control group. So they've been unable to discern any change in mortality or morbidity for the first 20 years, but they'll continue to look for another 20. At those low dose levels, you really wouldn't expect any. And I think at the time we calculated a maximum societal dose of about 1,000, 2,000 man round. If you multiplied 100 milliround at the fence times the people who live there, and you do it, all the way out to 50 miles or something. So if you used a linear hypothesis for relating exposure to cancer, I think we were saying at the time of the accident it might cause one additional cancer in that area over the next 30 years or something. Of course, that didn't stop the lawsuits. The lawsuit ran on and on and on and on. There were just thousands of people who thought that their health had been affected by the accident. And I just saw where the courts dismissed the final claims just recently. So no one was ever able to prove to the court that they had anything. But there were a lot of people who had health defects after the accident. I mean, it had the normal cancers, lung cancers, all other kinds of health. But, that goes on in as you well know, all the time. And the problem was trying to associate those with the accident. I had been at the island only a few hours, and we got this report that a goat died at a nearby farm. But fortunately, it was an old goat. Didn't have to worry with that one. And all the next year, there were always things coming into the commission that people thought were caused by the accident, and we parceled them out. One I remember particularly, about a year after the accident, was the report that there were more babies being born around Hershey and Lancaster and so forth with hypothyroidism than the national average. Hypothyroidism means that the baby has no thyroid or it's misplaced. And you immediately think of iodine. Could that be responsible somehow for this? And we referred the question to the CDC in Atlanta, which is the nation's epidemiologist. And I remember they wrote a call back to us shortly and said, we've looked into it, and we don't see any more incidents of hypothyroidism in the area after the accident than we did all the years before the accident and so forth, and that it's caused by consanguinity. Well, I was never taught what consanguinity was in my engineering school, so I had to ask, well, what the heck does consanguinity mean? It means all the same blood. And hypothyroidism is a marker of closely intermarrying communities. And with the Amish in the area where they intermarry, you have a higher incidence of hypothyroidism than you do in more diverse communities. And there's some other markers too. So CDC wasn't at all concerned by the higher incidence. It had always been there, and it will be there as long as they continue to intermarry rather closely. Here are some kinds of things you can face if you ever do get involved in an accident. All kinds of agencies began to put out in the country. You've got the national one, you got the state, you got the locals, you got the various experts who want to get involved. I believe, based on my experience, the best source of information is at the site. And I think whatever the kind of incident it is, whether it's Coca-Cola concerns or Firestone tires, you can't rely on having headquarters put out a closely worded and edited press release. You really ought to have someone near the site where the problem is occurring explain what's going on. So that's one of the things I have preached to emergency planning groups. What messages can you take back from TMI in general? The obvious one is always preach, don't become complacent, don't think you've got it all under control. We thought that prior to TMI and were rudely awakened. I think it's important to have a source of accurate, timely, and complete information for whatever kind of crisis, whether it's a spill on the railroad here of fuming sulfuric acid or nitric acid, whichever it was, but not, just level with the public, tell them the way it is. The public can handle the bad news and the good news. And put an informed source out there to talk about it. I thought the U.S. government made a mistake when they were talking about anthrax, and we had the Secretary of HEW talking about anthrax, but he really didn't know anything about anthrax, as you probably noticed, because he's not a physician. And finally, I ended up calling Governor Thornburg, who was governor of Pennsylvania, just like the head of HEW had been. I said, you really ought to get him some technical advice. I don't know if that call had any effect, but pretty soon you had some credible experts on anthrax, of which there are a lot in the country, began showing up in press conferences and talking about the anthrax. So I'm a firm believer in getting somebody who knows the topic, not to be the political spokesman, but to be the scientific spokesman. If you're ever the spokesman, what kind of advice can I give you? Well, it's the same thing. This advice is for someone who is attempting not to protect the company's interest, or where you're not worried about being sued, but your main interest is protecting public health and safety. And just be candid. Talk about what's going on to the best of your knowledge. Don't be judgmental. I really dislike precedent where people are pointing the finger. With Ford saying it's a Firestone fires and the Firestone guy saying, oh, it's a Ford trucks. You're just not getting any facts out of it. And then I final one is don't speculate. Don't get yourself trapped into saying what's going to happen tomorrow if you don't know what's going to happen tomorrow. So just stick to the facts and just lay them out there. The next period in the regulation then came for maybe the next 8 years. It was largely driven by millstone. There had been some questions about millstone, and the inspector had let millstone knowingly violate some tech specs relating to the spent fuel pool. This led the commission to take a very hard-nosed stand toward meeting the regulation. They kind of backed away from PRA, and the whole world became again meet the regulation, even if it's not the world's best regulation. So I'd say the commission sort of stalled around here for 8 years or so, trying to decide between using PRA and using deterministic methods. But they did make some progress. The maintenance rule got out. It was more of a focus on operations. Then finally, I was really surprised at the consequences of the deregulation. I thought when deregulation came, nuclear plants couldn't compete because many of them had rather high generating costs and that sort of thing. And it's just been remarkable how well plants are operating today. You can only conclude that back when they were monopolies, that there was a lot of fat in the system. They had too many people, too much money being spent. Today, they run these plants with a lot fewer people. They have very short outage times. They have excellent safety records. It's just remarkable how well plants run today. I think I saw where the average capacity factor today in our plants are over 90%.
Part of that being because there's a smaller number of entities working a larger number of plants, like Entergy and Exxon. Rather than have little offices at end.
I think it's worked out well where good running plants have combined. It's hard to see that TMI is that much better today because of being a part of Exelon. But the good plants that have gotten into big companies have just gotten better. Take the first energy plants like Davis-Besse or some of the plants that have had problems. It doesn't appear that consolidation has helped. So it's certainly got the potential, but how you apply it, is up to the company. Companies can still make wrong decisions. They can take too many engineers out of engineering, or they can cut back on training. So humans, can continue to pay for their mistakes. But there's been a lot of consolidation, and I'd say in general it's been good. The commission has also been quiet. They haven't felt the need for a lot more regulations, and regulation is much more now running on a PRA track rather than on a deterministic track. If you can't tell, I tried to show regulation as this lady with a shopping cart. Is she buying from solar power, or oil, or nuclear, or whatever? So I think the deregulation has really been healthy for the utilities, and the average price, as I mentioned before, of electricity is quite low. Finally, let's talk about what might be down the road and some ups and downs. And many of you will find yourself involved in these things because they won't be solved by the time you graduate. They'll still be around. Probably the most important technical issue that hit within the last year or two is the Davis-Besse pressure vessel corrosion. I mean, I think that really shocks everybody that you had this grapefruit-sized hole in the top of the reactor vessel. And I don't think the commission is through looking at trying to find how it went undetected. You have all these procedures. You've got the on-site review board. You've got the off-site review board. You've got the NRC. You've got the ACRS. You've got all the whole establishment. Nobody noticed that this iron oxide that was accumulating by the ton, represented a safety problem. And I have a theory about that I'll pass on to you. I think it's because maybe of the declining role of chemists and chemical engineering in the industry. That perhaps more attention to chemistry and material condition and so forth, and a little less attention to other things, someone might have picked up and asked the question, why are the filter banks in our containment always contaminated with iron oxide? Why are the monitors always contaminated? Apparently the plant manager used to pass this stuff around in the morning staff meeting, and they'd all look at this iron oxide, but no one ever thought it could be a serious problem. When the business got started, chemistry played a big role, and today I imagine I kind of think chemistry is going to play a bigger role. By chemistry, I mean materials, the interaction between the coolant and materials. So I think that's one reason. But the commission is going to push harder, I'm sure, on making sure the integrity of the primary system is kept. Second area that you're going to have some problems with is protection against terrorists. The commission has already raised the threat levels. They may raise it further. This requires moving the gates out further, putting in more guards, more detection. It's raising the cost of operating nuclear power plants. Some people worry about planes crashing into the plants. I don't think that's a particularly big problem myself. But if we have a lot of terrorist attacks in the future, a lot of people are going to worry that the reactor presents a greater hazard than it should, and will be pressing the commission to do more in security. So I'm fairly sanguine about the present level of security, but it just may be because I know a little more about it than the citizen. I actually think if there's a terrorist attack coming, I'd run to the reactor. It's probably the best place to be. Now, a couple of other technical areas that are beginning to just emerge, I call these precursors. There haven't been fuel failure problems in reactors in ages. I thought fuel failures were a closed issue. Actually, boiling water plants are now beginning to have fuel failures again. It may be because of consolidation. I think Framatome kind of owns all the fuel fabrication plants for BWRs now, and maybe they made a change in the process or something. But for the first time in a long time, I'm beginning to notice there are fuel failures that are cropping up. This raises exposure levels. It makes it harder to do maintenance. I mean, it has a lot of detrimental effects. You want to watch that one when you get out there and start earning all those big salaries for the power plants.
Longer fuel cycle.
Excuse me?
Longer fuel cycle.
Longer fuel, that may be a part. I haven't really tried to understand it. I just kind of noticed it. And then it seems to me there's a slight uptick in the number of significant events recently. For the past 2 or 3 years, the field has really been quiet. But now you can look at the steam generator tube failings at Indian Point. I think there was something at Fort Beach where the auxiliary feedwater system worked and was not expected. So it may be that maybe the cutbacks and the trying to squeeze the last dollar out of the plant may be at a level where you can't go any lower, maybe beginning to get some more failures. But certainly, the thing to watch is the commission publishes every year something called the precursor study, and they publish all the accidents, events that happen, and they try to plot them year by year to see if there are any trends. You might want to get a copy of that when the commission releases it in a few weeks and see if my feeling about this is really correct or not. Okay. Now, what are some good things? I'll conclude with those. Certainly the biggest good thing is the continuing good performance of the industry, both safety and reliability. For those of us who were around 20 years ago, it's just remarkable how well plants are running today. And none of the things I've noted above that can take away from that. I mean, today, I just sense when I go in a plant, there's a level of professionalism and attention to safety that just wasn't there a while back. I mentioned the consolidation. Early site reviews are now being seriously considered again. Exelon is thinking some, and someone else is also. And then there are some new reactor designs that are coming forth. So the field may be on the edge of a small resurgence. Of course, whether it really takes off or not depends on the availability of energy sources. If there's an oil cutoff or shortage, then you'll find a lot of interest again. If energy prices are cheap, then you won't find people building plants in a hurry. So when you're out there looking around who to work for, I can recommend my old employer. I'll end with that as a sales pitch for the NRC. We're always looking for good people, and I'm sure would love to have you apply.
Okay, we have time for a few questions and comments.
In the 60s and early 70s, when the water reactors were being built, the utilities were overrunning their cost estimates by 300%, 400%, 500%. In hindsight, and the aspect that I don't agree with, they blame that on licensing. Do you have any view on that which might be appropriate in future years for these youngsters who are new?
Well, the NRC had no capability with regard to estimating costs, number one. But they did have a lot of influence on the cost because we were coming out with a lot of new requirements at the time. And I think every little new requirement that the Commission issued maybe could be justified just by itself. It was kind of like if your children want only $1 today or $10 today, but if every day has another requirement coming out. So the NRC kind of unconsciously did run up the cost because there were so many requirements coming out. Now the rebuttal to that was that the utilities bought these plants before the plants were designed. They often bought a pig in a poke, as the expression goes. And then as the plant was being built, it had to be redesigned and had to be changed again. So I think the real answer to cost control is standardized plants. If you get it reviewed, get it approved, if the plant's fully engineered and it's fully reviewed, then there's no reason that they can't estimate the cost. But I don't know a lot about cost, I should say that.
I would think that in addition to standardized plants, the discipline that goes into the design goes a long ways to overcoming the issue of the increased costs. And my observation has been that discipline didn't exist in these utilities. And the NRC brought up the questions that would take the utility 6 months or more to respond to the question, which meant they didn't know what they were doing, and there were 2 or 3 more questions.
And I think, at least my view of the time, which may be wrong, since these utilities were monopolies, cost wasn't a really big thing because you could pass the cost on to your customer. So you're probably right about they didn't have good engineering discipline, but I don't think they paid a whole lot of attention to cost at that time anyway.
Let me make a comment since we're discussing cost. And Harold might want to add this, consider adding it as an up in your list there. But the cheapest way we have of producing electricity today is with nuclear power. All the utilities are in agreement for that, and that is the reason that all of the utilities are applying for license extensions of their existing plants, because it's the cheapest way today of producing electricity. And that's a real plus.
It's about 1 or 2 cents per kilowatt hour, and that is a bargain in terms of electric generation.
On one of your slides, you had the Rasmussen study, and you probably recall what they did is they identified certain types of failures, releases, and rates were estimated, and they realized they were not certain, so usually log normal distributions were assigned to that. And what I was wondering is if this was ever used. I don't seem to recall seeing it in the Rasmussen report, but I was wondering if this was ever used to make predictions. The Rasmussen report sort of seems static. You assess these probabilities, but you never really used it to make a prediction. And interestingly enough, if you take some of these rates and take the existing operating experience, you get some real probabilities. And I was wondering if this was what your sense of this.
The Rasmussen study had not been finalized more than one day before some people were attacking it as unduly optimistic. I remember the head of the American Physical Society. What was his name? Harold
Iverson?
Maybe, and there was one other.
Wilson?
No, somebody from the ACRS was on it too.
What you're talking about, University of Santa Barbara?
Yeah.
Harold Lewis.
Yeah.
Harold Lewis attacked this thing as being unreliable, speculative, and Congress, at least there were a lot of people in Congress who were opposed nuclear power, hauled the staff down to Congress, and we all had to swear that we weren't going to use PRA in licensing decisions because Harold Lewis said, so it put a damper for a long time on the use of it. Now today, of course, every plant has done a PRA, plant-specific, not a generic one, have learned a whole lot, and I think today the Commission is regulating on the basis of a plant-specific PRA. And if you go to a Monday morning staff meeting, say at Seabrook today, the plant manager has this chart of what are the risks this week of running this plant, and what are the operations that contribute to risk, and how have we minimized it. So today you'll find plants vary the surveillance times, the periods, and what equipment they're going to take out of service. So today it's part of everybody's thinking is keep risk to a minimum. So it's taken the years and years, 20 years for PRA to creep into the system.
Well, and if the designer has to do the PRA, he is much more knowledgeable on what's going on in the evolution of this design than if you didn't have PRA to it.
Sure. So today it's an integral part of the process. The NRC would not docket a new design today that doesn't come with a PRA.
Dr. Stevie?
We certainly are fortunate to have you living in the area, but I'm curious as to how that came about. How did you come to live here?
I have children here. Simple story. Well, I can tell you one more. I was going to retire to the coast of North Carolina, which is my home, and I owned a house down there. But the only thing they talked about on the Outer Banks, I found, at least for men my age, were prostate problems, blue plate specials, and fishing. And I didn't want to spend my life talking about it. So I wanted a bigger city.
Okay, as many of you are aware, we do have the people in cyberspace who listen to these presentations in our colloquium can ask questions and do ask questions simply by submitting an email to UTNE, and one of our staff is sitting there looking at all the emails during the presentation, and they print it and they bring it to me, and then I can read it and have the speaker try to answer the question. And so we have a question. You mentioned you previously worked at Savannah River. This is a former Savannah, it's a retiree from Savannah River. You probably know him. It's Dr. John Church. He has a couple of questions here. How did your experience and training at Savannah River influence your approach to safety?
Savannah River, I can say, was ahead of the commercial world when I switched from Savannah River to the commercial world.
Yeah.
They had the rigor of discipline. DuPont had built hazardous plants for years. They had technical specifications, which didn't get into the commercial nuclear world for a long time. So I found the experience at Savannah River to have been invaluable. And one other thing, I've always had this theory, that I can't prove, that if nuclear power plants had started being built by chemical companies rather than by electric power companies, we would have had a much more successful industry. Because I don't think the power companies knew how to deal with hazardous materials and didn't have the years that chemical companies would have had. I never proved that. That's a theory.
Okay, and then John has a second question. Can you comment on how you came to ask some of the DuPont personnel, namely Ben Rushi and Clark Ice, to come and help you in the TMI recovery?
We were getting help from everywhere. I tried to talk even more DuPont people to get involved, but I found that DuPont was concerned by that time about liability questions, and they didn't want to get people involved who might be subsequently held liable for decisions. So there's some hesitancy on the corporate DuPont level to get too involved. But as you know, GOE, once GOE got rolling, they offered up a lot of assistance. We were in the recovery phase in the first few days. So DuPont was singled out, but not any more than any other laboratory.
You called out a lot of people.
A lot of people, a lot of industry people got involved, and there was this. People originally thought that it was going to be a depressed economic area after the accident, and houses would be worthless and no one would live there. Well, actually, what happened? So many people moved into the area to accomplish the cleanup that prices soared, and it's a growth area today.
Okay. With that, let me remind everyone that we do have refreshments downstairs on the second floor, and everyone is invited. But before we adjourn for refreshments, let's express our appreciation again to Harold Denton for his presentation.
That's careful with the questions from my old colleagues.
Yeah. They see email and things.
Probably three colleagues. Good.